Number one, the free response question, number one from the practice exam 2 is what we're doing right now. And so let's just take a glance at the whole problem and then we'll jump into it. The particle we have given is moving along a line, classic setup. T is allowed to be between 1 and 8. And the formula for its position is this very interesting integral function. So wonderful, sounds like a ball. We're gonna have to find the velocity, looks like, for part A. So we'll need to take the derivative of that, which by the fundamental theorem of calculus will be not too bad. For B, what instant does the particle reach its maximum speed? We already have a velocity formula from A, and so we'll just consider its maxes and mins. And its mins as well, because we're thinking about the speed, not the velocity. And when is the particle moving left? We'll have to look at the velocity function for that to see when it's negative. And then we're looking for the last one, find the total distance traveled. Let's just, we'll take the velocity function, the speed function, and integrate it from 1 to 8, the absolute value of the speed, the absolute value of the velocity. So that's the frame of how we're going to move forward with this. Let's actually jump into the details. Again, bear with me for 1 second here while we switch to there. And again, the problem is small, off to the side in the little window. Okay, so let's take a look at this problem. And we'll need, this is a free response question number 1, so you know it's a calculator active question. And so we'll have to reach for a calculator eventually, but I'm not sure that that time is quite right this moment. For A, I don't think we need to do that. For A, we need a formula for the velocity. By the fundamental theorem of calculus, the velocity is just s prime of t, which dummy variable, it's just t. This is any number down here, it doesn't matter. It's just some constant, this is t. These match in here, so we're good to go. It's just what you see there with a t instead. So that's our final answer, and we're moving on for A, at least. For B, at what instant does it reach its maximum speed? We're thinking about what is the maximum value of that. And honestly, with a calculator, we could take a look at this, I'm trying to think if it's worth, I mean, certainly true that you can analyze V prime and then come back to V with that information, but as a calculator problem, I'm pretty sure the AP is gonna be okay with maybe you not even doing this. So we'll write the derivative out of this guy right here. Okay, the derivative is, of course, let's do first times the derivative of the second, that'd be t sine t minus cosine t, product rule, and then another product rule here. So like, again, I'm doing this, but I'm not sure that we have to do it necessarily. So here we get ln t cosine t minus 1 over t sine t. You can see that they intentionally calculated a problem. They intentionally made this like not very algebraically approachable. So we would be like wanting to, if we wanted to graph this, we could do it. We could graph this, set it equal to 0, find where it's 0. It's on this interval from 1 to 8. Is it ever undefined? No. So the only places we're looking for candidates as maxes and mins are these places where this is 0, where the velocity is 0, where the derivative of the velocity, the acceleration is 0, or endpoints possibly, right? Okay, so with that in mind, I think that's useful, but no one's gonna know really whether you actually did that or whether you actually just looked on the calculator and found the maxes or mins. So I'm actually, secret, don't tell anybody, I'm actually just gonna type this in into y1. So bear with me for a second here. So I'm typing in 1 in y1, 1 minus x cosine x minus the natural log of x times sine x. I'm just going to type that in. And actually, I don't know, if you want to type in the absolute value of that, you could, or you can just, as you look at the graph, you can just kind of consider for each one of those values that yeah, maybe I'll do the absolute value of all that stuff. Okay. Anyway, or you can just consider it when you graph it that you know, if it's a negative value, then that's all you care about. So I'm going to graph this on the interval from 1 to 8, obviously, and yeah, let's see what that looks like. So sorry, this is low tech, but I'll just, can you see that okay on there? You probably can't. Oh, you can. Here, I'll put it. No, I don't know. Anyway, so I'm getting, well, how about I sketch a little picture of it up here? I'm getting a picture that looks something like this for this function here. Looks something like, I'll put a picture down here. For v, this is v. It looks something like, on this interval from 1 to 8, looks something like this. Yeah, something like that. All right. All right. So the point is, we're trying to find the max. So what does it actually say? At what instance does the particle reach its maximum speed on the whole interval? So like we're talking about absolute maximums here, right? So you can already see from the picture that it's that values, one of those two. It's actually a little hard to tell. It looks like it's maybe this guy down here that's actually a little lower. In absolute value, again, it would be like up above if you graph the absolute value. It would be up here somewhere. So let's just test each value. I think AP is going to want to see you test all 4 values that are available to us, though. So for that, let's actually put in some t values and calculate the speed at each of those so that we can compare it at 1, sorry, there are 5 actually. There might be another one in there too. It may actually go uphill just a little bit right there. I can't tell. So let's just start calculating some of these values. At 1, oh, actually, you know what? I graphed that wrong. It's kind of more like this on this interval, and then it goes up over there. So honestly, I think we're doing pretty well here. It just does. Really, there are only 4 things to put on our list, like we said. Okay, so that value is 0.4597, okay? And at 8, it's 0.1067. And then I don't know what those values are. Let's find those here. Maximum. So that maximum there is at 3.732, and that's 4.8334. I'm giving you a few more decimal places just for fun. And then minimum looks like it's somewhere between 6 and 7-ish or something. So 6.700 approximately, and -5. Well, or sorry, if we're doing the absolute value, all these 5. So we were right. 5.8. I think that's 98. 4, whatever. If you want some more decimal places. Okay, so what are we supposed to do again? At what instant does the particle reach its maximum speed? It didn't even care about its maximum speed, actually. It just asked when that happens. So the answer to that is at t equals 6.700 seconds. Or there are no units, so whatever. Okay. All right. Sorry, we're just kind of moving a little more slowly than we'd like on this here. Remember, this is a picture of V, just in case we need it again. This is a picture of V, right? Because I think we might need to consider that one more time as we look at these. C says, when is the particle moving to the left? Well, we've seen a picture of the velocity graph now. The velocity is positive, and then the velocity is negative after this 6 point. That's supposed to be, sorry, my graph is not perfect. Yeah, that max, yeah, right there. Yeah, it's about right, actually. 6.7, so we haven't found that 0 yet. What we need to find that value maybe on our calculator, and then it's from there over. So we're looking for where V of t is less than 0. When is the particle moving to the left? On this interval, on the interval something to 8, right? And that'll be our answer. So I have this still in my calculator in Y1. So I'm just gonna find, looks like it's at 1, 2, 3, 5 ish. All right, so you find the 0 on your calculator. It's calculator reactive problem. It's 5.204. All right, so that's the answer to that. When is the particle moving to the left? Okay, I think we got that. We're good on that answer. And then finally for D, it asks, find the total distance traveled by the particle. And for this, we're gonna be looking for just the absolute value. It's a calculated problem, so you're fine just doing this. The integral from 1 to 8 of the absolute value of V of t dt. I have this in Y1 already. I'm getting called by my children in the background. It's delightful. It's precious. So if you integrate from 1 to 8, the absolute value of V of t, that is the speed. And you can just do FNN on that, right? So that's what I'm about to do. I already have this in my calculator in Y1, so I'm going to just type in integral on my calculator FNN from 1 to 8 abs, like the absolute value function on your calculator, ABS, of Y1. And I'm just going to do it like that in one move on my calculator. So when you do that, you get, wait for it. So from 1 to 8, math, num, abs, and then Y1. And I'm getting, wait for it, approximately still thinking. We should look up all the answers in the back here too. It's having a major issue with me here. 1 to 8 absolute value. I feel like I'm leading you in the right direction here. We're trying to find the total distance traveled from 1 to 8. Why would my calculator be struggling with this? It's trying to integrate this. Wait, let's see here. From 1 to 8. Like I said, it's perfectly well defined. I don't know what its issue is. Sorry, everybody. Let's let's check the answers we have, and then let's go to Desmos with that last problem. I'm trying to think why that's not coming up. I don't know. That seems like that should work, but sorry to leave you hanging there. Okay, so the answers to this question are exam 2. 6, yeah, so we have A correct, B is correct, C is between 5.20. Oh, shoot. Okay, so didn't notice this. There is, wow, who knew? This actually rises just a little bit above the x-axis there. So I led you astray, my friends. Turns out that actually goes positive at 7 point. Oh my goodness. Why would they do that to you? 7.987 is where that goes positive. Shoot. All right, whatever. And then the last answer should come out to be 21.461. So I will now hop over onto use something else here. I don't know why my calculator is not working on that, but it's not. So I don't know. Okay, so let's switch back to Desmos here. And I'm going to graph this function. V of t is equal to 1 minus t cosine t minus ln t sine t doesn't really like this function. Ln of t sine of t. Okay, there we go. Maybe I just, okay. On the interval 1 to 8 here, get a nice look at that function. And now I'm just dying to see if it has any issue with this. From 1 to 8, absolute value of v of t dt. There we go. Okay, I don't know why. So that's what I had up on the board. My calculator was just having an error with it. I'm not sure why. So that's the answer for that last one, and we are good to go then.